Welcome to Study Loop.
Okay, so this is a projectile problem. So we've got a really terrible looking gun here, and this gun is going to shoot something and it's aimed straight, right? But we all know when you shoot a gun, it's going to drop. The bullet actually falls, right? And so we're trying to figure out what's this distance that it falls, delta y. So we know the horizontal distance is 200 meters. And we know when this thing is shot, it's going to come out with some x component of velocity, and it's going to come out with no y velocity, right? So normally we would have an initial y velocity, but in this case, it's going to be 0. And the key here is that these two dimensions are independent of each other. So how this thing behaves this way, this is a bullet traveling at a constant velocity in this dimension. But in this dimension, it's accelerating. So I have to treat these two dimensions different. So I'm trying to solve for the thing in the y dimension. So I got to take my x dimension stuff and solve that first. And in the x dimension, it's in a constant velocity. So the only equation that applies here is velocity is displacement over time. And the horizontal displacement is 200. So I can use this to figure out my time. I can figure out how long this bullet is going to take to go from here all the way down to here when it hits over here. So if I rearrange for time, I get time equals my horizontal displacement over velocity. And that comes out to 200 meters divided by 400 meters per second. And so I get a half a second. So this bullet's going to take a half a second to go from here to here. And in that time, it's going to fall this distance, right? So now let's take this time and use that to figure out how far it's going to fall. Okay, so we'll go to the y dimension. So in the y dimension, the only equation that applies here is y equals 1/2 g delta t squared, right? Because there was no initial velocity in the y direction, this thing was shot horizontally. So I don't even have to do any algebra. So it's just going to equal 1/2 times 9.8 times 0.5 squared. And if you do that, you get 1.225 meters. So 1.225 meters is how far this thing falls. Okay, so part B, this is part A. So part B says, well, when you shoot a gun, why do you have to aim up, right? How come he has to adjust his gun sight barrel so it points a bit up? And the reason is because gravity is pulling things down in this dimension, right? If you take your gun and you aim it straight, even though you aim it straight, what really happens is this thing is going to fall some, right? So instead of doing that, I need to take my gun and I need to aim it up a little bit here, right? So that it'll go up and it'll fall a little bit and it'll come and hit my target right there. That's why you have to aim a little bit higher than your target, because there's nowhere you're going to get away from gravity.